Hey guys, happy holidays. I hope you guys are well. I am today home from college for winter break, and I left most of my stuff at college, but I do have some things that I'm going to work on while I'm home, and I thought I would just show you guys really quickly how to build the FSR trigger circuit because a lot of people have asked me that, and I thought it would be better to just show it in one simple video so that everyone could see it and I would never get asked that question again, even though I probably will, and that's okay because I love answering questions. So, without further ado, this is how to build the transistor circuit for web shooter triggers in case you don't want to use a button trigger, in case you want to use a flat trigger like this one, because this is like just stealthy and you can put it under a glove, you can put it under anything. It's fantastic. Okay, let's get started. So the things you will need are an FSR. These run pretty expensive. You can get them from Amazon for about $13 each, which is a lot. eBay, you can get little smaller ones, which work really well for, let's see, I'm not sure. You can get 6 of them for like $20, so that's pretty good. Don't quote me on that, might be wrong. I actually found a really good deal on these ones, though, at my local Micro Center store. You could buy them there for 2 for $13, so that was really cool. You will need stuff for your web shooter, solenoid, stuff like that. This is my battery allegory that I'm using today. It's a 9-volt battery, and since I left most of my stuff at college, I'm just using Scotch tape to tape the wires to it. I know it's not ideal, it doesn't look good, whatever. I'm just here to show you guys how it's done. This is a transistor. This is a power transistor. It is a TIP122 power transistor, and you don't have to use a power transistor. You could use a regular transistor, but this I think is safer for applications where you're using a load on the transistor. For instance, solenoid, which is a coil, which could cause some overload of current for the transistor. Anyway, this is an NPN transistor. You can use a PNP transistor, but the circuit is different, just slightly. I'm going to just show you it with a NPN transistor. So yeah, let's get started. For the solenoid, we are going to use an LED and a resistor instead, just to show you that it can be done. So first thing we're going to do is hook up our battery to the breadboard, just like this. As you can see, I've attached the red positive wire to the positive line of the breadboard and the black negative wire to the negative line of the breadboard. So that's the first thing to do. We've created our web shooter circuit background, if you will. And next thing we're going to do is put a transistor here. And the way this transistor works, you can just put it anywhere in the board. The way this transistor works is it is base, collector, emitter, left to right this way, base, collector, emitter. How this is going to be hooked up is the solenoid is going to run from the positive line of the breadboard to the collector. So we need to attach this like so, because the positive line of the battery is going to give us our current, and then the collector is going to act as a negative in order to collect the current from the LED. So the collector is in the middle of the transistor. So we're going to connect it just like that. Whenever you're using an LED, it's important to have a resistor, just because LEDs can draw too much current for themselves. So a resistor helps that. And pretty much, yeah, don't not use a resistor ever. Any kind of resistor works though, no matter how small. Next, the base of the transistor is going to attach to one of these leads of the FSR trigger. So we're just going to put that directly here. All right. A bit twisted. All right, so this is what we have so far. As you can see, the FSR is connected to the base of the transistor and an open line here on the left side, and the collector of the transistor is connected to a resistor, which is connected to the negative of the LED, and the positive of the LED is connected to the positive of the battery. All right, the next thing to do is to just connect the emitter of the transistor, which is the rightmost pin here, connect that to the ground. All right. That was difficult. Okay, so we've connected the emitter of the transistor to the ground of the battery. The last thing we have to do is worry about the other pin on this trigger. So the other pin on this trigger has to go the positive of the battery. Has to go to the positive of the battery. So the way the transistor works is that there's more than 0.6 volts between the base and the emitter of the transistor, then the LED will turn on. So you can see this is not a button, this is an FSR. What that means is it's a force-sensitive resistor. So when it's off, it's infinite resistance. When it's on, there's less resistance, but there's still some resistance. What we want to do is have no resistance on this LED. So we use the transistor to turn this kind of not digital signal. It's not on or off. It's fluid. It's definitely multiple values of resistance depending on how hard I squeeze it. But as you can see, there's no in-between on the LED. It's just on or off, which is exactly what we want for a solenoid valve. So this is the circuit. As you can see again, transistor, LED, resistor, force-sensitive resistor trigger, battery, and a couple of wires. That's pretty much all you need.